this video, we'll be looking at deforestation, we'll be looking at ozone depletion, and then we'll also be looking at water availability if the time permits. So in the previous video, we finished off with looking at afforestation. So afforestation is basically the planting of forests or trees. Now, deforestation is the permanent destruction of natural indigenous trees and bushes by felling or burning in order to clear an area for its purposes. So just to give you some statistics, so every minute, a forest the size of 20 football fields, now that's just a little bit smaller than a rugby field, is destroyed due to deforestation. And the Amazon is one of the rainforests that is heavily impacted by this, especially with illegal logging. So this is the Amazon rainforest on the right, and this is a portion of it that has been cleared for agricultural purposes. And on the right here, it's also just to show the destruction or the aftermath of deforestation. So what are the causes of deforestation? Majority of it is because of human population increase. So we need room for urbanization, so housing developments, wood for fuel, mineral mining, agriculture to feed all of those people, timber to build these developments with, and then traditional medicine. So these are all of the causes of deforestation. So what are the effects of deforestation? The biggest one is soil erosion. So trees' roots actually anchor the soil, and they hold it, the roots of the trees hold the soil together. Now, when there are floods and these trees are removed, the soil gets washed away. And also, the flood has a much bigger impact on that area because the roots of the trees are no longer there to absorb the water. Then there's also loss of biodiversity, as lots of these trees are habitats for anything from insects to larger animals, and now they are gone. Then the disruption of the water cycle. Trees play a major role with evaporation and transpiration, and once we remove trees, there's a major portion of water that is taken away from the water cycle. And then lastly, global warming. So trees are carbon sinks, which means that they absorb carbon dioxide during photosynthesis. Now, when there's less trees around, there's more carbon dioxide in the atmosphere, which leads to the enhanced greenhouse effect, which then in turn leads to global warming. So everything is connected. So this is just an example of how severe soil erosion can impact an area. So the possible actions that you can take to reduce the effects of deforestation, you can just go through all of that, but basically recycling paper, support the use of recycled products. A lot of companies are going electronic, they are sharing things electronically, so there's no more paper trails. Create protected forest areas, combat illegal logging, plant trees to replace those cut down, and the list goes on. Next is ozone depletion. So the ozone is a layer of gas that is located around the Earth in the stratosphere, and it is a layer of the Earth's atmosphere, in case you didn't know what the stratosphere was. So on this diagram, you can see the various levels of the atmosphere. I cropped the picture a bit to make it fit there, but this layer here is the stratosphere, and then that very fine layer is the ozone layer. Now, ozone is necessary because it absorbs the harmful UV rays from the sun, and the depletion of the layer leads to the thinning of the ozone layer. So the effects of depletion is vast. So firstly, there's damage to human health, such as skin cancer, cataracts, and then weakened immune systems that can be caused. Damage to marine life, so phytoplankton is destroyed. Damage to agriculture, so the world's major food crops, wheat, rice, barley, corn, soybeans, and oats, they are very vulnerable to ultraviolet radiation. And then damage to materials, so plastic, wood, rubber, and textiles and other construction materials are broken down or weakened by ultraviolet radiation. So this has a ripple effect once again. So let's say there's an earthquake in a certain area, and the structures, materials have been weakened by ultraviolet radiation. The impact of that earthquake could be much more severe than it would have been if the ozone layer was still intact. So next we are looking at water availability and the factors that influence water availability. So construction of dams, destruction of wetlands, exotic plantations and depletion of the water table, water wastage, cost of water, poor farming practices, droughts and floods, and then boreholes and its effects on aquifers. So constructions of dams, so there's two very large dams that I've given you an example of down here. So why do we need to build dams? Firstly, for flood control. So river levels can be regulated and we release small amounts of water into the river. Then the water supply for human use. So water is collected and stored for us to use throughout the year. Then electricity generation, such as hydroelectricity. So basically what happens is water is pumped from the dam into the dam wall where there are turbines located, and then the water is pumped at a high pressure, causing the turbine to turn, and that in turn generates electricity that can be used. Then irrigation to water crops, obviously. Now, when we construct dams for our personal uses, there are also quite a lot of disadvantages. So there's loss of biodiversity because we are destroying habitats up and downstream, because now there's no longer water here, and at the top there's damming of water that is occurring, so the water levels are rising and causing water to be in areas that were never before flooded. Then migration routes of fish are blocked, for example salmon. So salmon need to swim upstream and to be able to spawn, and now that can no longer happen because, well, there's a dam wall. Then water loss through evaporation. So water evaporation leaves behind salts that can also lower the water quality, but now the surface area of the water is so much bigger, and that means that more water is lost through evaporation. Then soil erosion. So rivers are drier downstream from dammed areas, and there is also then less sediments being deposited that can lead to soil erosion. Seasonal flooding of the rivers. So when the river floods, there is fertile sediment that is deposited on the river banks, but now because of the dam walls that is stopped, so the soil fertility downstream decreases. Then communities that have to move, so lots of people settle next to rivers because it's a source of water obviously, but also a source of food with fish. So now because it's dammed up, they don't have that access to the water anymore. Moving on to the destruction of wetlands. So wetlands are areas of land that are saturated by water, and these include floodplains, pans, estuaries, riverbanks, wet grasslands, marshes, swamps, and springs. So those are all examples of wetlands. So I've added quite a few different variations down here, so of pictures, so you can see the different types of wetlands. Both of these, I think, is from the Okavango Delta. This is also an aerial view of the Okavango Delta, so you can see how vast this area is in real life, actually. Then you've got marshes and swamps, as you'll find in North and South America, and then estuaries. So this is where rivers flow into the ocean, that portion over there. So wetlands are generally areas that have a high water table. There's many aquatic plants, and it's also generally very rich in biodiversity, so there's lots of different animals in the area, waterlogged soil. And then why they are important, they can be used for flood control. So wetlands are basically like a massive sponge. So if there's a flood in the area, the water gets spread out and slowed down, so it decreases the impact that the flood will have on that area. Then they can also purify water, and they act as filters. They can store water and replenish the water table, and then obviously they increase the biodiversity for that specific habitat. So what are the factors that affect wetlands? So wetlands are drained to plant crops and to create grazing areas. Overgrazing results in soil erosion, incorrect placement of dams pollution, mining, and then urban development, where they'll actually cover wetlands in order to be able to build in that area. So we are still busy with factors that affect water availability. So the next is exotic or alien plantations and the depletion of the water table. So basic exotic plants are plants that come from another ecosystem and they are then established in a new habitat. Now these plants will always need more water than the indigenous plants, and they generally have better developed root systems that enable them to get to that water. Now forestry in South Africa plays a big role with these exotic alien plantations because they are done with wattle, eucalyptus and pine trees, which are all exotic trees. As you can see down here, that's what those plantations look like. I'm sure you've seen them when you drive towards Nelspruit, that area. There's quite a lot of them there. Then possible actions to reduce the effect of alien plants. What can we do? We can create awareness of the negative impact of alien plants. We can remove them. Specifically the wattle trees have popped up in areas where there's no forestry happening. So those trees definitely need to be removed. Encourage the planting of indigenous plants or plant plots of indigenous vegetation in commercial forests. Next is water wastage. So there's various ways in which water can be wasted, specifically in your home as well. So not fixing dripping taps and leaking pipes can lead to a lot of water being wasted. In fact, over here on the right hand side, there's a little statistic here. So a leaky faucet dripping at the rate of 1 drop per second can waste more than 3,000 gallons of water per year. Now a gallon is equals to 3.7 liters of water. So if you times that with 3,000, it's quite a large amount. Then using dishwashers and washing machines. Washing machines I can still understand, but dishwashers use quite a lot of water and you can just have a quick wash of the dishes. Then bathing and not showering. This uses a lot of water. So if you want to save water in an easy way without compromising with your luxuries, then rather take a shower instead of bathing. Then washing hands and brushing teeth under a running tap instead of closing it while you're lathering on the soap or if you're brushing your teeth. Watering the garden during the hottest time of the day. Washing your car with a hose and not a bucket. And then just some more interesting statistics. So the average American shower uses approximately 15.8 gallons of water, or that equals around almost 60 liters of water, and it lasts almost 8 minutes. Whereas the average bath uses between 111 and 185 liters of water. Now just imagine those 5-liter jugs, and then that amounts to quite a lot of that. 1 toilet flush also equals around almost 6 liters of water. So think twice before you flush. I'm just kidding. Another thing that affects water wastage or that wastes water is poor farming practices, such as using spray irrigation instead of drip irrigation. So spray irrigation here on the right hand side, these two are examples of that. And the reason why they are bad is because the spray of the water, a lot of it that never ever reaches the soil because though the water gets evaporated before it can touch the ground. So a solution to that is drip irrigation, where pipes can be installed underground so that the water is directly it directly gets to the roots, or if the water just drips above the plant, there's less evaporation that will occur then. And then lastly, pollution. So pollution of freshwater sources through sewage, industrial waste, detergents, cleaning agents, fertilizers, pesticides, and then radioactive waste. Poor farming practices, so we just spoke about poor irrigation methods. That also influences water availability. So overgrazing and incorrect plowing methods, they are also a big thing. So overgrazing in an area is when there are too many livestock in an area and the vegetation cannot support that. So you can see on the right hand side in this picture, this farmer here has a problem with overgrazing, whereas the person on the left hand side doesn't necessarily have that. So this area will be stripped bare, and this can actually lead to the process of desertification. Then incorrect plowing methods. So incorrect plowing methods can cause erosion. So there's certain ways in which soil should be plowed in order for it to not cause runoff of water. This also comes down to the topsoil. So the top layer of the soil that is high in nutrients, that gets washed away. And then the water holding capacity of the soil will also decrease. Next one is boreholes and their effect on aquifers. So groundwater is used for drinking and agricultural processes, and they are replenished by rain or snow that will infiltrate the soil. So this is the groundwater then, and then it moves through the soil until it reaches a point where it is saturated, and that is then the water table. So water seeps in, and then it fills the underground water sources. And then an aquifer is an underground permeable layer of rock that is saturated with water. And then water from an aquifer reaches the surface through a spring or a fountain, and then some groundwater sources can take very long to replenish that. So what happens when we take out groundwater faster than it can be replenished, for example with boreholes? So with this, the water table is then lowered. So let's say the water table was here. Now we remove the water and it drops down to a level down there. The soil can actually collapse when the groundwater is extracted and not replaced. And underground water does not support the soil. So basically this will then be an air-filled area, and you could get the soil that will then collapse because the water is no longer pressing up against it. And then also when groundwater like this is removed close to the coast, salt water can actually seep in, and that can basically replace the fresh water, and it will become undrinkable. Then water quality. So what is water quality? It's the physical, chemical and biological properties of water. And factors that reduce water quality is eutrophication and algal bloom, domestic and industrial and agricultural use that leads to pollution and disease, mining, alien plants, and then thermal pollution. We'll look at all of those. So domestic pollution, when you use detergents that are not biodegradable or very harsh chemicals to clean with. And then also pathogens that can be found in sewage, such as cholera, they can cause cholera, gastro, typhoid, all of those. And these are example of such pollution that end up in our water. So people dumping their rubbish at water sources, for example. Industrial pollutants, so heavy metals that can be found in water, such as lead and mercury. Oil and petrol spills, BP oil spill is the first oil spill that comes to mind. That happened in 2012, if I remember correctly. There's actually a movie with that with Mark Wahlberg. Paper and pulp mills and textile factories that release various salts into the water, as well as thermal pollution. So what this means is that water that is basically boiling is released into freshwater systems, and that will kill anything or any fish that is in the surrounding area then, because it cannot grow in such warm temperatures. Agricultural pollutants, pesticides and herbicides that flow into water, artificial fertilizers rich in minerals that infiltrate the groundwater. These then flow into dams and rivers, where it can cause an increase in growth of freshwater algae or algal bloom. This is a memo from a previous exam paper. This is from a grade 12 paper. So it just tells you exactly what eutrophication is. So it is the addition of high levels of nutrients, especially nitrogen and phosphorus, to water. And this you generally find in fertilizers that are used in agricultural areas. So this causes or it is caused by allowing untreated sewage to flow into rivers or wetlands. Also when fertilizers gets washed into streams and rivers, or when fertilizer industries pour waste into rivers and streams. The extra nutrients then allow the algae to grow. They grow very quickly and they cover the surface of the water. The rapid growth of the algae is called an algal bloom. You need to know what an algal bloom is, so that's the definition of it. And then certain algae and algal blooms can release toxins into the water. This is, for example, a red tide. The algae become overcrowded. They eventually die due to the lack of sunlight. Bacteria in the water then decompose the dead plant material, and they then use a lot of oxygen during the decomposition process, and as a result aquatic animals, fish, insects and so forth die due to a lack of oxygen. So that is eutrophication and algal bloom described pretty well. So this is what algae looks like, and you can see that this fish has succumbed to that algal bloom. Algae can take over a whole area of water covering the surface. Here you can't even see the water, and this is at the Yellow Sea, where they've got a very bad algae problem at the moment. Well, not at the moment, but during that time when that picture was taken. How can we prevent algal bloom and eutrophication? Use precise quantities of fertilizers to prevent excess runoff. Inject fertilizers below the soil surface to prevent runoff. Use specific combinations of fertilizer to suit each phase of growth, and then install more water treatment plants in affected areas. So with this, they could have asked you what is algal bloom and eutrophication, and then just to add more to this essay question, they could have, for example, asked how to prevent algal bloom. So you could have added that into that question. Then mining, specifically acid mine drainage. It is the drainage of highly acidic water from mines onto the surface of the land or into groundwater. And these pictures are great examples of that. So acid mine water is formed when groundwater flows over the rocks in old mine shafts and tunnels in gold and coal mines, or just the mines releasing their runoff into the rivers as well. And this water then dissolves in sulfide minerals out of the rocks, which forms sulfuric acid. And this lowers the pH of the water, which in turn dissolves metals out of the rocks. These metals include toxic heavy metals such as manganese and radioactive practices. And then the radium and uranium are radioactive elements which release radiation into the environment. This is very harmful, obviously, to living organisms. The acid mine water gradually fills up old mines and it rises to the surface, where it spreads out and pollutes rivers and wetlands, harms or kills plants and animals. It also moves into underground water supplies, which may be used for irrigation and drinking, and will therefore harm plants and animals in this way, and humans too, obviously. So how can we reduce the effect of mining on water sources? So mining companies should be held accountable for their damage, and they need to rehabilitate the area efficiently, and then the quality of the water should be closely monitored during and after mining activities to assess the impact on the environment. And I'm going to stop this video right here. In the next one, we'll continue with alien plants in more detail.